Right.
PhD agak tua apa ni? Sebenarnya kalau ikut tahun dah tak cukup, dah 8. Tapi bulan 8 hari tu dah cukup. Ya, siapa nak sambung cepat lah, saya nak minta
Kau saya nak PhD.
PhD?
Serius.
Apa FYI?
Masa FYP dia, dia sama FYP dengan saya dulu.
Siapa macam bagi tahu.
Dia sangat rajin, dia sangat lebih bagus dari saya.
Akak nak apply FR tu.
Maksudnya kalau dia pada betul sebab masa dia buat solar.
Siapa?
Yes. Maksud dia kata sebabkan dia buat masa kat Inten. Lepas tu susah tau buat solar tu. So macam kesian lah, masa dia macam lama sikit lah 3 tahun. Lepas tu dia nak bayar pada. Lepas tu dia kata macam dia rasa nak buat PhD dekat UTS sebab asal dia nak kerja kat Singapura, nak kerja kat Singapura. So dia kata lah. Saya kata dia apa nanti kau buat ni PhD HMM kita sekarang sebab dekat dia aku invite lama gila je buat HMM kita. So boleh je dia buat sini aku lama gila apa ni
Akak nak bagi dia announce dengan yuran sekali. Kena apply ni. Tapi akak tak ada student, akak nak apply dia. Tapi akak tak dapat dulu apply.
Serius. Doktor, kalau doktor apply dan tak dapat grant ke, ada segi doktor akan dapat grant bila?
Dapat grant tu 11.
This year.
Siap.
Okay, so sempat bila maybe dia akan daftar next year yang tu 3 bulan.
Ya Allah, dah dapat student.
So serius.
Susah kot,
Sebab saya memang cakap dengan dia.
Akak ada baik
Dia memang
akak rasa
ada.
student local.
Tapi dia kata dia kalau jumpa dia sebab dia perempuan lah, dia overseas dengan saya. Dia saya macam, dia cakap kita.
Kita comel lah.
Nanti sangat lembut. Tapi depend tau. Sangat lembut, dia sangat overseas dengan saya. Dia macam,
Kawan masa degree dulu?
kau yang baik, daripada kau yang baik.
Ramai macam mana sama siapa kan?
Dan tidak lah. Dia nak sambung lah.
Kalau ada, tak payah buat apa. Akak rasa kalau sambung kan, kalau dapat announce dengan kerja, kalau dapat announce dengan baik dulu dan semua, kita sambung. Sebab duduk je kat sini, kalau dapat lecturer yang okey, tak payah pun nak datang ikut ahli pancun 5 hour, 8 hours tak payah. Dan jadi siap kerja. Kalau boleh cara juga siap kerja, datang lah jumpa.
Saya rasa dia libat semua tu. Dia libat, dia semua hilang.
Hilang kan? Tapi kerja siap. Terima kasih. Bos. Okay, bismillahirrahmanirrahim.
Dia nak start aku.
Kita tunggu apa ni korang? Sadia tengok sikit sebab dia naik grab.
Kalau boleh lelaki dia kata. Bukan yang
Untuk makan lah apa lah. Memang mungkin lah. Diorang pun dia keterpaksaan. Tak ada apa yang boleh dapat kecuali tak apa, akak faham je kalau orang tak ikat. Sebab kalau akak pun ada keutamaan benda lain kan. So ambillah Allah sedang membantu akak untuk memiliki kebaikan dan lain. Okay, bismillahirrahmanirrahim. Kita bertemu dengan nombor kitab Al-Fatihah. Alhamdulillah, welcome to the training. Terus even though we only have 3 pupils here, 3 students, I hope that all of you can pay attention lah. Okay, we can solve it together. Let's move to our first phase, ice breaking. Ice breaking girls. Guna dia tahu dah apa ni. Yes, saya. Okay, ice breaking. As normal practice, I need you to describe in this paper, okay, the things that you like. Read, drawing. Okay, in case apa saja dalam ni yang kamu suka, without write anything. Okay, and then your date of birth. Date of birth. Raw. Nak balik long je 10 jam. Itu 10 jam dapat dia hari ni. Boleh kata masa pergi hantar anak sekolah tadi apa yang tak datang. Lagi lah. Adalah sebab kawan ada stretching kan. Kau balik akak pick up PTL.
Oh, tinggal tu dah pick up macam mana tadi?
So dah ready dah kat rumah. Diorang pun dah packing semua siap. Nanti akak balik. So cuma hari ni mesti dia lagi buat ready dulu. Okay. Can I collect? Thank you. Thank you. Thank you. Alright. It's gonna break first thing if you have more people. So, okay. And I have this. Right. Can you guess who?
I know. This is from Izati.
Izati.
Because she like to eat Maggie.
Maggie, they want Maggie or coffee?
Maggie. Because in fact she eat Maggie.
Oh, really?
In fact she eat Maggie at the hotel also she eat Maggie.
Did you know her date of birth?
Of course.
Of course, you know her date.
Yes, I know by years.
By years.
Not the date but the years.
Thank you, Richa. What about you, Izati? What's that? Green tea. Original tea.
Sing. Kalau aku suka kopi lebih macam.
Macam tu apa? Warna tea. Like one cake, a piece of cake. Dessert. Nice, nice, nice. Okay, kita tengok kali lagi ni. Cuba. Okay, what about you? Apa tu? Okay.
Ten.
Salah. Okay. The one at the back. Apa tu? cloudy one. Cloudy. Thank you. You? Of course. What's that? So you can ask her what that she like.
Please guess. What type of food I like? And then what kind of food?
Comic or else subject.
What? Fictional? No. I love to read spiritual, motivational books. For now, I into that book. Yeah.
What type of person are you, Aisha?
Me. I think everyone know that I'm a talkative person. I think I just cry when I sleep. So I think I'm very extrovert person. I think that describe me. Just one word, talkative.
Did you know her?
She don't know me.
Did you know her?
I always come to this because she always watch movie.
Okay. Something like that. Okay. Can keep that. So finish our ice breaking session. Thank you, girl. Okay. Let's go. Okay. At the end of the session, participants will be able to analyze this okay. Actually, in previous session, we already covered this is a key. Okay. But we have our new participant today. So I need to recall that and revise. Okay. At the end of the session, participants will be able to analyze this is a key by using basic analytical laws. Okay, we have several laws in solving the analytical circuit. Okay, understanding Ohm's law, Kirchhoff's law, current and voltage divider, differentiate all the methods of analysis, total and mesh analysis. Alright, I think I should use the pointer. I put okay, to see the flow of movement of electron through a material. Okay, we have an electron. Electron inside the material. So the movement of the electron we call as electricity. Current, the rate of flow of electrons through this one we can call as speed of the electron. So the rate of flow of electron through a material. Okay. We have two types of currents. We have DC and also AC. Direct current and alternating current. Okay. I believe that most of you have understand well about the DC current. Okay, understand well. Several laws and also the fundamental things. So the focus on today is to analyze AC current. AC current and also the power. We also have 4 types of power, which are instantaneous power, we have average power, we have complex power, and also the apparent power. Okay. Quick overview for you. In the AC circuit and DC circuit, okay. For DC circuit, okay, we only have the real power. Because of what? Okay, because it consists only resistor. Okay, no inductor and no capactor. we include the AC circuit, okay, move to this AC, we already have the reactive power. Q, we have complex power, S, apparent power, S, right? So, if we combine with both AC and DC circuit, we will have S equals to P plus J Q. Okay. This one is actually, I always told my previous student that to use complex power to calculate all types of power. S is equals to VI conjugate. This is the formula of complex power. By having this one, you can actually got S equals to plus JQ and S. This one real, reactive, and also this one apparent. So you just need to calculate the one and only complex power. You will have this P, Q, and also S. How did you get? S, VI conjugate, you can get in phasor form. Phasor form like this. For example, 1, 2, O, 30 degree in phasor form. And the other one, complex form. For example, 119 plus J 731. This one is considered S, apparent. This one, P. And this one, Q. Okay, we have go too far, so we go back to our slide. Now, AC circuit. This is the waveform. AC circuit compared to the DC circuit. DC circuit, just one line. Okay, while AC, sinusoidal. Right. Next. Okay, alternating current. This is the symbol, and this is the symbol of DC current. We move the charge Q equals to IT. Okay. It's placed with time and also current to calculate the charge. One. Let's go. Okay. The example of the DC circuit is your batteries. Handphone batteries, laptop batteries, remote battery. Okay. They want all DC supply. AC, our connection up there in the room. Okay. They want to play with the AC circuit. Okay. So bear in mind that DC circuit just only include this one, resistor. While AC, we have inductor and capacitor. Different unit. AC in ohm, inductor in Henry, capacitor in Farad. To calculate all the parameters, all the component, you must convert it to ohm. So that you can combine to calculate the current of series circuit. Okay? Now, let's go. P equals to IB. This is just stands for real power. Sorry, real power. P equals to IV for DC circuit. While AC circuit is turned to different value or different things. Like this. S equals to VI cos theta V minus theta. This one P equals to IV only. P equals to IV only for DC circuit. For AC circuit, S equals to IV cos theta V minus theta I, because this S consists of P plus JQ. The real power one and also the reactive power. Okay? Which includes capacitor and also inductor. Right? Next. Current flow. Okay? If power have a positive sign, power being absorbed by an element. Okay? This one. Absorbed by the element. Okay. Let me make it clear from here. We have active and also passive element in the circuit. What does it mean by active element? Active can supply, while passive just can absorb. Okay? For example, active voltage source and blah blah blah. Passive element, resistor, inductor, capacitor. This one can be categorized as passive element because they cannot supply, they just can absorb the power. Okay, if no power, no action. Okay, no power, no action. They can't do nothing without power. But the active element can supply the power to them. Okay? They just can't absorb the power. Right? Next. Okay, this is the terms, quantities and units. We have charge, current, voltage, energy, power, resistance, capacitor, inductor, basic impedance and reactance. Okay? Laju. Okay, this one. Okay? Next, I move to the nodal and mesh analysis. To solve the circuit, we have nodal and mesh analysis. Okay. Now, I focus on this one first. Node, branch, mesh, loop. Node, branch, mesh, loop. Node. What is node? Okay, guys. What does it mean by node? No, I want to start with branch. Branch is the section that have one element on it and ended with two nodes. Okay? Branch, how many elements here? 1, 2, 3 equals to 3 branch. Okay? Loop or mesh. For this example, 1 loop. What about node? Node a joint between two or more circuit elements that being represented by dot. Okay, for this one we have 1, 2, and also 3 nodes here. Okay? Different with this next example. In this circuit we have how many branch nodes? Can you calculate for me? How many branches in this circuit? 5 branches. 1, 2, 3, loop? 2 loops. And the last one, node. How many nodes in this circuit? 1, 2, 3, 4. 4 loops. Got it? Okay. Next. I want to focus on the, let's see, the AC one. This example. Right. Now, look at this example. Find the voltage and currents indicated below. Okay, we have 30 volt voltage source. We have another 3 branch here. Passive element. This is active element. Power supply. We consider as passive element and active element. There is 3 resistor as passive element. We have 2 loops in this example. We have 1, 2, and 3 nodes. Okay, we have 2 loops. Okay, for this example, so we can calculate the value of voltage and current. How? Okay, we have several methods. We have 2 and more methods to solve this problem. The first one, you can gather all the resistors. Okay, by calculating R equivalent. How to calculate the R equivalent? You must identify it is parallel or in series connection. So, R equivalent depends on the series and the parallel connection. You need to start from the last one, the last node. You need to start from the last. So, this R equivalent equals to 6 parallel with 3 and series with 8. Oh, 6 parallel with 3 plus 8. Now, we move to the second part, nodal and mesh analysis. Easy also. Nodal analysis, you need to use the value of voltage. Nodal. Okay? But mesh analysis, you need to use the value of current. It's play around with current. Nodal analysis, play with voltage value. In mind, okay? Nodal analysis. Okay, now, from the beginning, you can choose which analysis you prefer. Okay? Either mesh or nodal analysis. My preferable. I love to solve the equation by using mesh analysis. Up to you. Okay? We see after this. Come on. First step in solving circuit by using nodal analysis, you need to identify the nodes. Because of nodal, it plays around with the nodes. You need to identify and choose the node. Okay, then by using or by having that node, you can have the equation. For example, in a circuit, you have 4 nodes in the circuit. So you're going to have 4 equations. If you have 2 nodes in the question, you will have 2 equations. For mesh analysis, if you have 1 loops, you only have 1 equation. Okay, but if you have 4 loops, you will have 4 equations. the difference. Very easy. Okay, you can choose. You can select. Okay, you prefer nodal analysis or mesh analysis. If you want to play around with the voltage value, you can use nodal analysis. If you want to play around with the current value, you can use mesh analysis. Alright, let's move. Okay, reference node. In the nodal analysis, you should select the reference node. Basically, in the ground part. Okay, at the bottom of the circuit. Okay, we set as reference node. Okay. Next, leveling node voltage. Okay, for this one, we have 3 nodes, right? So we're gonna have 3 equation. This is considered 1 node. Okay, 2 node. Okay, and also this 3 nodes. So we have 3 equations. Okay, for nodal analysis. The first one, set up or label the nodes. Then choose your reference node. And the third one, provide the equation. Only 3 steps to solve the problem. Good. Now, identify the node. Node 1, node 2, and node 3. But set the reference node 3 as reference node. Consider as V equals to 0. This reference node, the value of V naught equals to 0 volt. That's it. Okay. Then what is the equation? Okay, you only have node 1 and node 2. Because this node 3 considered as reference nodes and the value is 0. So, we can start from this node. Current entering the node is equals to current leaving the node. This node, okay, what current entering the node? You can see the current supply. Okay. How many current supply inside this? 1 and 2. Your node is here. Entering the node. Which current entering the nodes? Okay, now. Which current entering and which current is leaving depends on us. We can set the direction of current. Except for current supply. We cannot change it. Right? So this current supply remain. The direction is remain. So entering the node and this one leaving the node. Okay? But for these two, R2 and R1, we can set the direction of the current. Okay? You want leaving or entering? Leaving. Okay, you can get this leaving current. Okay? To the ground. And this one to the right. Okay. Set the current direction. Because of what? Because you want to set the equation by using the direction. For example, itu kamu kena. Ya, kejap. Kalau ni guna terus habis. Dalam kelas terus habis maka setiap hari ganti maka. Mana nak habis dia nak kejap. Ada macam ni.
living. So I1 equals to I2 plus IR2 plus IR1. Like that. Entering equals to living. Then we go to the voltage equation. Now, I1 supply, no need to change. I2 supply also, no need to change. We need to change this one. IR2 to what? IR2 equals to V1 minus V2 over R2. Remember the Ohm's law? V equals to IR. To change the I, we need to set V over R. So, V1 minus V2 over R. What about IR1? V1 minus V0 divided by R1. Simple as that. Okay? Why we need that current direction? Because we want to know where to start. If your current flow to this ground here, so you need to start from the tail. V1 minus V0. If your current entering the node, how it be? V0 like that. Okay. That's why the importance of the current direction. Okay? Same goes to here. Let's see. This one, which current entering the node? I2 entering and IR2 entering. Leaving IR2. Okay. So you will have two equations in this question. Okay? You can solve it by using calculator. Calculator lah. Okay? Simultaneous equation. Simultaneous equation dalam calculator. Tak payah kira ni. Kira nanti salah. Guna calculator Tapi kalau dalam AC dia susah sikit. Sebab AC kalau simultaneous equation tu dia tak boleh insert. Dia nak insert the complex number. Right. Next. Like that. Okay. We set the direction of current first. And we provide the equation. Now, I1 V1 minus 0 over R1. I1 mana I1? I1. Okay. I2 V1 minus V2 over R2. Then I3 V2 minus 0 over R3. Then you can have the equation. Equation 1 and 2. Dan habis. Habis deh. Solve lah. Solve. Kalau ada value, you can solve. Yeah. Right. Next. Calculate the node voltage in the circuit below. Okay, same. But saya akan cakap. V1, V2 and V3. Okay, how many equations in this question? Can you predict? Okay, first question. How many nodes here? Okay. Let's start. V1, V2, V3, V4, V5. But this 110 is series circuit. Okay? This dulu. Tolak sini. Tidak. Kalau nak buat, boleh buat note kat sini, tak ada masalah. You can set this note also, guys. Okay, how? You can set this note also. So, please, first thing first, current direction. When you have supply here, of course your current will be there. Right? You will be here. Right? I1 here. I1 is actually 10 minus V2 over 100. Okay? Repeat. Okay? I1 entering this V2 node. So, I1 actually start from here. Here, start from here. Series. Okay? Actually start from voltage source. Right? You need to take that voltage source with you to put in the equation. I1 is equals to 10 minus V2 over 100. What about I2 here, guys? V2? V0? Very good. What about I3 here? Very good. Okay. Three loops, easy to solve. So actually we have 3 equations. Okay. Next, let's move to this one. I love this one. I love this. Why? Because we just play around with the current. No need to decide which direction. Actually, you need to decide. But I prefer clockwise. Current direction, clockwise. Okay? Let's move. So, if we have 3 loops, of course, guys, we have 3 equations. Okay, directly. 1, 2, 3. Okay, look at 3. This one. Look number 3. We already have this current source. But we set the direction of current is clockwise. It's different from the current source. What happened to this one? Very good. Opposite direction. So I3 equals to negative 10. Super. Fantastic. So that one is our current. Mesh current. Our current that we decide before solve the equation. So I need you to tell me this current refer to what? Between loop 1 and 3. Can you? I? No. Okay, this I1. I2. I3. What about current in the middle? Very good, Shahid. Top student. Okay. I1 and I3. This one, I0 is in the middle between I1 and I3. So we need to take this I1 minus I3 because of what? Why not I3 minus I1?
Because the direction of the current.
Because the direction of the current is same. This is clockwise, right? So this one also clockwise. So I1 minus. What about this one, guys? Yes. I1 minus I2. What about this one?
Saya pernah belajar dulu. Main mean. Okay, 2 ohm plus 8 equals to 10 ohm. Right? 10 ohm. So you already have this R equivalent. R equivalent is 10. So how to get the value of I total? V equals to I R total. This is Ohm's law. Okay, V equals to I R total. I R total, R total similar with R equivalent. Right? So you can get the value of I. I equals to V over R T. 30 over 10. So you get 3 ampere. 3 ampere actually located here. Okay, 3 ampere is located here. Overall or total current for this circuit. Then you need to find current entering I2 and also I3. You can use current divider rule because this is parallel circuit. So how can you calculate this one? I2 equals to, take the neighbor value. 6 over 6 plus 3 times 3 ampere. I total. So you got no need to calculate the side, the other side of current. Yes? Because IT equals to I2 plus I3. So I just write it as I2. I1 equals to I2 plus I3. I1 is actually 3. I2 3. 3 and 30 and divide. Right? I2 and I3. I2 is equals to 2 plus I3. Like that. So directly you can calculate the I3. Of first method. The second method you can use nodal analysis, and the third one you can use mesh analysis. Okay, now you already got the V. Find the voltage and current indicated below. Find the voltage V1, V2, V3 by using the current value. You can have this V1, V2 and also V3 by using Ohm's law. Okay, V1, can someone answer? Okay, V1, 3 times 8, 24 volt. What about this one? 6 volt. This one? Also 6 volt. 6 times 1 ampere. Okay? Settled. Current indicated below. Okay. You have current value I1, I2, I3, and also you have V1, V2, and V3. So, okay? Let's move. This is the answer. Move. I1, I2, I3, V1, V2, V3. Now, about this one, voltage across resistor and series. Voltage different in series circuit. Current different in parallel circuit. So for parallel circuit, you can calculate the value of current. For series circuit, you can calculate the value of voltage. Easy, simple. That's that. Alright. Now I want to move to the power one. Power one. Let's move to the power one. AC circuit. Okay, previously DC circuit, which is just include the R for DC. Now we have RLC in AC circuit. Okay, in DC again, in DC we just have resistor. For AC we have R, L, and also C. R, ohm, L, Henry, C. Alright. Okay. This one we need to convert to this ohm unit first. Okay. Look at here, guys. Girls. Okay. RLC. How to calculate impedance for R? Z equals to R. That's it. For L, Z equals to J omega L. L equals to Z equals to J omega L. Why? Why you need to do this? Because you need to change this unit, Henry, to ohm. Compulsory. Right? For C, 1 over J omega C. Why? Because we need to change this farad to ohm. Okay? Admittance, what was up? Okay. Z equals to R. Z actually impedance. In circuit, we have R, L, C, Z, Y, X. This one stands for resistance. This one, inductance. This one, capacitance. This one, impedance. This one, admittance. We also have G, conductance, subsistence S, but I'm not cover that one. Reactance. So Z is actually R plus JX. Okay, total of R and also X. X can be XL. It also can be XC, and it also can be XRLC. X and C. Right? So this impedance is summation of R and reactance. So this reactance can be either XL, XC or XLC. Okay? Now, step in analyzing AC circuit. Transform the circuit to the phasor domain. Solve the problem using circuit analysis technique, nodal, mesh, etc. Okay, current divider rule, voltage divider rule, Kirchhoff current law, Kirchhoff voltage law, up to you. Transform the resulting phasor to the time domain. What is time domain? Time domain is T equals to I dt. This one, TT. Time domain. Okay, time domain. Because in the AC circuit, we have the magnitude of voltage. We also have T here. Okay, and the magnitude of current and T here. Okay, IT and VT. Like that. So we have IT and VT. Okay, that's meant by time domain. Right, let's move. Given a circuit with the nodes, select a reference node, assign voltage V1, V2 to the remaining N1 nodes, apply KCL to each node expressing branch current in terms of no voltage. Solve the resulting simultaneous equation to obtain unknown voltage. Let's go. This one. Itu susah. Example pun tu susah. Okay. Now, identify all the passive elements are in ohms unit or not. Okay. For this example, easy for you because all the passive elements are in ohms unit. Oh, maybe no need to change. Okay. J negative J13 for capacitor, J4 ohm for inductor. No need to change anything. You just need to calculate as usual. Okay, for this example, get handles. Let's solve it together. Right. I prefer to calculate the R equivalent or Z equivalent. In this AC circuit, we cannot focus on the resistor. Okay. Now we already have the impedance, which is the impedance is R plus J X. Okay. R and X. So for this example, we need to calculate Z equivalent or Z total for this circuit. So start from the letter, the last one of the passive element. We have 10 ohm plus negative J13, okay, plus 4. Right? This one parallel with 3 plus J4. Right. This one plus 5. So you will get the answer. Right? Okay. And series with negative J13 and also series. Connecting in series. 4 plus negative J13 plus 10. Okay, you can solve this first and parallel with this value 3 plus J4. Sum up with this 5 ohm. You will get the value in ohm. Okay, what happens next? You can get the value of, okay, you want this one, right? This one, Vx. Then what you can just simply do, you can have mesh analysis here, or you can start from the I here. I here is equivalent to I total. I total entering the nodes equals to I1 plus I2. To calculate V here, you need the value of I. How to get this value? By having this I total. Okay, first of all, let's calculate the I total first. V equals to I Z equivalent. Right? No more R equivalent, no more. In AC circuit, we're focusing on Z or impedance. No more resistance. Right? So, we can have I here. IT, V, you can take the value given over Z equivalent. Okay? So IT equals to V over Z. Still Ohm's law. V equals to I DC. This one for AC. Okay? Now, after having this I-total, you can calculate the value of I2. I2 flow through here. See this again. This one, see this again.
How?
I2 equals to 3 plus J4 over 3 plus J4 plus 4 minus J13 plus 10. The total of the impedance. Okay? And times 2 I. This is current divided rule. Take the neighbor value. Neighbor value where? Okay. To calculate I flowing here, you need to take the neighbor. 3 plus J4 over 3 plus J4 plus 4 minus J13 minus 10. Solve.
Any question until now? No? No question?
Okay. Then, what is your example? Apparent power, volt, ampere or VA to this thing.
Now, we move to the power.
Calculating the power for this easy circuit. Right, those apparent power is the product of the RMS value of voltage and current. It is measured in both amperes or VA to distinguish it from the average or real power, which is measured in watts. Okay. The new things. Right? P. Unit for P. Watt.
S. Apparent power.
Good. Okay. Actually, it was the same. P equals to IB. This one also IB. Right? IB cos theta. But this one we are using what? This one volt ampere to distinguish between them. So we use S as VA, P as watt. Same actually. Okay? Beza dia dekat unit saja. Now, the apparent power
P, we are using this one. RMS value. V RMS, I RMS, cos theta V minus theta I. This cos theta V minus theta I
is actually power factor.
cos theta V theta I is actually power factor.
You need to use this theta V theta I to determine if either that one lagging or leading power factor.
How can you know?
Leading power factor. Hello?
Later we move to that power factor. How to determine lagging or leading?
Okay? Right. Now, apparent power as this one. Power factor, this one. Cos theta V minus theta I. You actually, you know this one. Right? Power factor is equals to cos theta. This power factor very important in industry. Very important because what? If they got PF less than 0.85,
industry in Malaysia needs to ensure that their power factor more than 0.85 to avoid the surcharge. Okay? They need to pay high if less than 0.8. That's why the power factor is quite important in calculating the AC circuit. Okay? So, we have this one, apparent and power factor. This is actually PF equals to cos theta is actually cos theta B minus theta I. Not only theta. Theta what? Theta B minus theta I. You can determine the circuit leading or lagging by referring to this theta B minus theta I. Okay? Leading means V leads I. How leads? Like this. For example, we have two types of sinusoidal waveform. The first one V. The second one I. This one V, the first one V, the second one I. By having this waveform, can you predict which one leading and lagging? V is leading I. V lead I. While I lag number. Okay? Low speed. Okay? That I. Low speed. Then V. So you can simply tell that V leads I or I leads. Okay, so theta V minus theta I should be in positive sign. So cos theta V minus theta I in negative sign called as lag. Lagging. Okay, only two terms. Okay, then let's move. Okay, now PF equals to P over S. Boleh kita lihat di sini. PF P over S. If we have real power and apparent power value, if we have that, we can use this formula. If not, PF, the actual one, cos theta B minus theta I. Where did you get this one? By V and I. V and I in phasor form. Okay? V and I in phasor form. For example, calculate power factor for V and I. Calculate power factor for V and I. Okay. So, you can calculate what?
VI cos theta V minus theta I. Right? This one is actually PF. PF is actually cos theta V. Which one theta V? 90 degree minus 30 degree. So the power factor will be 0.5. Leading only. VEI. Okay. So directly you can get the value of power factor if you have these two V and I, because we have this theta V and also theta I. Right. I'll 5 minutes break. 5 minutes break. 5 minutes break.
Dia tak ikut kan?
Nangis ha. Akak nangis lagi. Install rescue tool boleh dapat balik yang kita format. So,
Dia dapat?
aku dapat dah dulu. Dapat 2 video yang lepas.
Yang hari ni boleh buat ni?
Ni sebab dia macam ni, dia full term dia box. Akak just dapat yang first 30 minutes. Dia dah porak tu maksudnya dia dah diformat kan. Tapi akak korek balik yang belum
So, ni nanti betul combine kan? Macam tu buat banyak kali kan?
sebenarnya full dia 4 hours.
Dia tak nak sambil ke siapa?
Sambil kat website ni Syams. Kalau dia panjang lagi masa, buat lagi lah. Apa cerita ni? Laptop tak ada sekarang. Dia masih
Saya
dia update 14 saja.
Dia lama tak masuk bilang sendiri. Nanti
Lebih kan? Tak ada lah. Kalau suka sikit, mesti boleh jawab. Sikit ni sampai habis sikit. First ni apa? Sikit teori. Ya kan? Sikit teori.
suka analisis.
Sikit analisis. Lepas tu,
Suka analisis.
lepas tu naik pula ke power system. Power system lah. Kan power system ada sikit juga kan? So naik sikit ke voltage.
Tak lah.
Naik tak naik.
Tapi yang penting saya tak ada suka lah.
Tak sikit eh.
Power
Ada
voltage.
macam pasal ni.
Teori je.
Dia bosan sikit.
Sebab lecturer yang ajar tu dia pro. Macam okey lah.
Semua biasa sebab lecturer kan pada macam ni juga. Ni bakal lecturer. Tapi dia determine nak jadi macam ni. Lecturer yang mengajar sana. Akak belum yang mengajar aku. Nervous tau. Study dengan student. Sebab nak mengajar. Korek juga ada dia.
Saya ikut Ilyas, dia macam ni lah kelas dia. Ataupun macam yang Dewanti.
Macam-macam. Kalau combine,
Okay, macam UNI, UTM juga.
memang tak recognize all lah, memang tak boleh lah. Tengok tu macam tu kan, tapi tunjuk berapa. Kat sini maximum 60. Kalau dapat 2 section pun 60 lah. Sebab satu section kat sini capping dia 30. Kalau awak tengok ramai tu 2 section lah tu.
Uni sebab dia nak lecture kan.
Dan teaching track dia sangat beban. Maksudnya kat sini dapat 9 je. Soalnya dapat 12, 18. Macam daripada cikgu pula.
Tak cari pun dia suka ada lagi.
Belajar lah.
Cakap cari ni kan, dia kan tengok lah. Kalau tak lagi tu dia macam kilo melan. Macam mana dia bertambah?
Ada dia cara ajar masing-masing lah. Sebab kan ajar, seorang ajar dia tak boleh memuaskan semua pelajar dia. Sebab karakter pengajar macam lain. Karakter student ada 4 types. Tak boleh belajar 4 types of learning punya karakter. Dia ada lah cara dia. Kalau lecturer ni tak kena dengan dia punya type, dia akan tak suka. So lecturer satu, one karakter only. So it need to distribute to 4 types of learning character, which is 4%. We got 4 learning character. Okay. Can I ask you your type of learning character? Muna suka lecturer je. Dia kena ada movement, right? Kena ada eye contact. Kita tengok. Ada seorang tak suka, dia tak suka lecturer tengok dia. Tengok saja. I stare at you saja. Like or not? Okay, your learning character. Which type of lecturer character that you like? Lots of problem in the class. Not in terms of assignment of quiz. You don't like it. Okay. Suka lecturer yang kelakar.
Saya okey je mana.
Okay, cuma mana.
Sebab saya akan ikut rentak lecturer tu. Saya akan
Kejar dia.
Ada kalau lecturer macam tu, saya ikut cara dia. Saya tak tahu sebab dia tak ada bising pun. Saya jauh pergi dengan mana lecturer. Saya tak ada preference lah.
Jadi macam yeah. Actually, all lecturers memang nak buat code. Notes, example. Note example. But masa kejar course information. In 14 weeks, you need to cover 8 chapters. For example, 8 chapters equals to how many hours? So that maybe limit to the example. Okay lah. Yeah. Excellent student, all of you. Excellent student can cope with that. Any character of lecturer, teaching style. Tapi bear in mind when you be a educator, okay, when you entering the academic field, you feel that you cannot make everyone satisfied. Of course, okay? We have our own character, and we have to face their characters, so that not all can suit with us. Not all. Some of you, some of them. Okay? Can we proceed? Now, let's move. Okay, this is definition of the power factor is the cosine of the phase difference between voltage and current. It's also the cosine of the angle of the wave. Okay, cosine of the angle of the wave. Okay. Okay, this is what I said just now. Could be used to show the type of the wave. Current like voltage, negative EF. Okay. Previous example. Current like voltage or voltage lead current. Okay, can be either one. Okay, current like voltage, negative. Current lead voltage. Current. Back. Current like voltage, negative power factor. Or else voltage lead current. Okay. Voltage lag or current lag. Voltage current lead or voltage lag. Okay. So look at here. For inductive load, this theta V minus theta I. If you get this one plus theta, okay, or this one. Can look at this one also. PQS. Theta, positive sign. So this is lagging PN. For power phase, how we call this one? Phasor diagram. Phasor diagram. This is phasor diagram for power. Power phasor diagram. Okay, we also have voltage phasor diagram, and we have current phasor diagram. Okay, next for capacitive load, this is leading PN. Okay, we draw it like this. Power phasor diagram. Okay, power phasor diagram, negative Q or positive Q. Positive Q, lagging power factor. Negative Q, leading power factor. Okay. If the circuit only has inductive load, we consider as lagging power factor. Or else, if capacitive load, we consider as leading power factor, because the Q will be negative. Right. Okay. Current in phase with voltage. Current in phase. Itu cara dia overlap dia. Okay. This one voltage and this one current. Okay. No one lag, no one lead. So in phase equals to unity power factor equals to 1. Okay, because in phase, V and I are in phase, overlap each other. Okay, unity power factor. Right. So we have purely resistive, purely reactive, resistive and reactive load. R, L, O, C, R and L, C. So this gonna be, the impedance gonna be Z equals to R. This one Z equals to no R. So J, X. This one Z equals to R plus J, X. Full term. R plus J, X. This one Z equals to R, Z equals to JX. This one Z equals to R plus JX. 1 P over S equals to 1. All power are consumed. This one P over S. Sama. Macam ni dia. P over S macam ni. Kenapa? R equals to 1. And R equals to 1. Why? R, you can get the leading power factor because of this one. You can use PF equals to P over S. If your value of P and S is equal one, for example, this one can what? This one can VA. So you will get what? Because of what? Your P and S are equal. Okay, you will get unity power factor. For resistive load only, girls. Okay. For P equals to 0, no real power consumption. How is that? PF equals to P over S, right? P0 over S. So it will become 0 power factor. Right. And the last one. Lagging or leading. This one lagging inductive load, leading capacitive load. You can have this lagging and leading in RLC circuit, not in the LOC circuit, and not in the R circuit. Only you can get this lagging and leading in RLC circuit. Okay, bear in mind. Right? So, next one. Summary of power factor goes P equals to V RMS times to I RMS cos theta B minus theta I. This both VI is equals to S, which is apparent power. Okay, the last one cos theta B minus theta 1 is actually power factor. So let's turn to the Q, reactive power. Q equals to VI RMS sin theta B minus theta I. This Q is sinus waveform. This is cosine. Okay, this is sine, this is cosine. S sin theta B minus theta I. So S is equals to apparent power. Same goes to this one. And no power factor. Because sin theta B minus theta is not power factor. The power factor is this cos theta B minus theta I. So for the calculation, S equals to V RMS I RMS. This is modulus to calculate the apparent power. Okay. We have same symbol S and S. This S is actually apparent. Okay, for me, I want to teach you in my style. S modulus is actually apparent power. So what is S? Complex. So actually this line, we should have this one, right? This one is referred to apparent power, not this complex power. The formula are different. Okay? For complex power, we use VI conjugate. RMS also. This one RMS, this one RMS. But for apparent power, we use VRMS, IRMS. Like that. No conjugate. Okay, cos. Yeah. Let's go. Okay, go find the complex power delivered by the source if R here equals to 20 ohm, L equals to 3 Henry, and IT, this is in time domain form, 1.25 cos 5t minus 15a. Okay, if you have this kind of form, you need to change to Phasor form. This is time domain form. Time domain. Got T here. Time domain form. You cannot solve by using this time domain form. You need to change to Phasor form. Then how to change it, girls? We have parallel circuit here. one. Now, here is 20 ohm. Me 3 Henry. This one 1.25 cos 5t minus 15 degree. Okay. The first thing that you need to do is what? To convert Henry unit to ohm unit. Okay? Henry to ohm. Okay? XL equals to J omega. Right. Okay? Omega is actually 2 pi. Right? This omega you can get from this one. Right? 1.25 cos omega t actually. This one 1.25 cos omega t minus theta. Okay? Our omega is actually 5. Theta is 15. Okay. To convert IT time domain to phasor form, we need solve it first. J omega 5 and 3. So we have here J15. Convert already. Ohm unit J15. Okay? So to solve this one, you want this as equals to V and complex. Right? You need to have this voltage value. Okay? Or else I squared Z. I squared Z. Or V squared over Z. Now, VI, V equals to IZ, I equals to Z equivalent. How to get the Z equivalent? I ni macam ni. Ya. Time domain to phasor domain. Okay. 1.25 cos 5t minus 15. Okay. Phasor domain, it will be like this. 1.25. Right? To convert time domain form to phasor domain form, 1.25 cos 5t minus 15 degree, it will be 1.25 over sec t 15. So we can use this value to get V, right? So V equals to I Z. I equals to V over Z. Okay, betul lah. I, you can take this value 1.25 sec 2. Okay, to the angle of 50 degree. Z, what about Z girls? ZEQ. So our ZEQ is actually 20 parallel with J15. Now you will have V value. Okay? Okay. Yes. How can I? This time domain form is actually V max. We need to convert to V max. VRMS equals to Vmax over Z. This time domain, actually, time domain for IT equals to IM cos omega t plus theta. Like that. This is the actual form. IM cos omega t plus theta. But we need in the phasor form. Phasor form is actually VRMS equals to VM over Z. Right? To convert and domain to phasor. Get it? So, at last you have this value. Then after you having that V, after you having this value, you can have S equals to VI conjugate. What does it mean by I conjugate? I conjugate, you need to change this value to positive sign. Okay, positive sign need to change to negative sign. That is meant by conjugate. Okay, so your S complex will be V, I don't know V, you need to calculate by yourself. Okay, I is 1.25 over Z2, there's one positive figure. Okay, so you will get S value. S value in phasor form. S value in phasor form is the apparent part. But S value in rectangular form is P plus JQ. Real active. So by having this complex power, you will get 3 values. By having this complex power, I repeat, by having this complex power, you will get 3 values, which are complex power, 4 values. Complex power, you will get S value apparent. You will get also real power P and power. That's it. That's why in the calculation you need to calculate complex power first. If you're having this one, you automatically you can have all these factors of power. Okay. That's the tips. No need to calculate the apparent. No need to calculate the reactive, real power, the average power. No need. Okay. You just need to calculate this aspect by changing the sign, changing the I sign. Okay. Negative 15 to positive 15. Then you will have to get this all types of power. Okay. Untuk supaya kita nak cari yang lain. Nak calculate Q, you need to use that Q formula. Q equals to VI sin theta V minus theta I, right? If you want to calculate P itself, you need to have VI cos theta V minus theta I. It's hard, right? You need to recall all the formulas and calculate. It's hard. So you just need to calculate the complex power and you can have all this type of power. Okay? Now, you want to try? Nanti tengok resistor, 32 mH inductor, and okay, this one, there is no circuit in this question, but you need to develop it by your own. Develop it by your own. Okay? I sentences. 90 ohms the 32 amp adapter, 5 microamp capacitor are connected in series across the terminals of sinusoidal voltage as shown. Okay, the steady state expression for the voltage source be as 750 sin 5000 V plus 30. Construct the frequency domain equivalent circuit. Series of signals connected to series. So simple as that. Okay, series circuit. You have the voltage source. Okay, and then you have resistor, inductor, and also capacitor. This is 90 ohm, 32 mAh. This one 5. I'm sure. I3. Very good. Opposite direction. Same direction. Okay. Kita buat question. Come on. Mari. Nampak. Okay. Mari kita buat. Kita punya. Okay. This one. I1. Buat ikut suka dia lah. Nak letak I1, I2, I3. Okay. You need to decide which one. Okay. I1, I2, I3. Okay. Clockwise. Okay. Now, we should have 3 equations because we have 3 loops. Now, loop 1. Okay, go back. Loop 1. Loop 1. Okay, this one negative V1 masuk sini. Okay. R1 V equals to IR punya equation. I apa tolak I apa? I1 minus R, I3, R1. Yeah? Okay. We focus on I1 first. I1, of course, I1 at the first place. Okay? So, I1 minus R3, I1 minus I2. Okay. Here, the equation. 11 I1 minus 8 I2 minus 3 I3. This one after solving. Okay? After simplify. Okay? You can get this. Where it's come? Okay. Sebab B1 okay? Next. Loop number 2. 6. Okay, go back. Senang saja. Loop number 2 mana ni? Okay, come on guys. Negative itu okay. Easy peasy. Easy squeezy. Okay, good. So after solving all the equation, you can have this one simultaneous equation inside your calculator. No need to calculate manually. Okay, please. Semua salah. Saya dah berpengalaman maki. Kesian nak bagi salah. Sebab kita salah. Equation betul. Supposedly the answer must be same. Must be true. Salah. Correct. Nak bagi macam mana? Nak bagi jawapan berdasarkan, nak bagi betul berdasarkan jawapan last ke? Kita tengok kat method. Okay, you give me an extra. Okay, another pass for you. Okay? Not easy to be a lecturer, but welcome to the lecturer life. Okay, soon, lecturer life. InsyaAllah.
pay something to our nation. Give something and get something. Okay? If you give more and you get more. Sure. Okay, come on. Two loops. Of course, you will have only two equations. Okay? That's two. Two loops only. You need to solve lah. I think you know already the answer. Okay? I will give the assessment for you guys. Okay? 5 questions for assessment 1 and 5 questions for assessment 2. Okay? It's help you to improve your understanding. Okay? Okay. Find the current through by using. Okay. This is the critical part. Okay. You will get that assessment. It will say to you, by using mesh analysis tool, by using mesh analysis method, you cannot use nodal. You doesn't have any choice. You need to solve that question by using mesh analysis. Or else, find the current through after using nodal analysis method. You need to use nodal analysis method. You don't have any choice. Okay, this is to remember in your final exam, previous final exam. What question appeared in the paper? Mesh analysis or nodal analysis at the time? Not remember. Okay. A few years ago. And of course. Okay, now guys. I jump to the AC circuit. Okay. Previously in DC circuit, quite easy if you know and understand well about the KVL, KCL, Ohm's law, current divider rule, voltage divider rule. You know well in mesh analysis method and nodal analysis method. But in the AC circuit, you just add 2 more elements, which are capacitor and inductor. So the equation, the solution will be different. Okay? Because now you need to calculate also the capacitor value and also inductor value. Okay? By using impedance value, Z equals to R plus JX. Okay? Now we start having that complex number, G. Okay? Did you, I believe that some of you didn't bring your calculator. Mine also, I didn't bring my calculator. Well, hey, I bring that. Oh yeah, yeah, I got. Okay, for AC circuit, you need to change your calculator into complex mode. How? Menu. And then complex mode, number 2. So, the I will appear. Okay? In the to calculate the theoretical between the AC and DC, it's just that. Change your mode to complex mode. And but it's not easy as I say that. Okay? There is certain step that you need to follow. Okay. Now, okay, look at here, guys. Before this, we only have one value. For example, let's say V, voltage. You only have 10 volt like that in DC. 10 volt, 12 volt, 20 volt. But for this AC circuit, you will have the longer value. Longer value. 750 sine 5000 T plus 30 degree. Okay, guys. It doesn't matter about sine or cos, cosine or sine. Okay. It's just different from the start. Like that. Sine start from 0. Sine wave start from 0. We call as sine wave. Cosine we start from 90. omega is angular frequency. Omega equals to 2 pi f. Relate to frequency. You can calculate the value of frequency by having that value. 5,000 omega equals to 2 pi f. Omega is 5,000. 2 pi f. Okay, can you calculate to me what is the value of f? Omega equals to 2 pi f. Omega is equal to 5,000. 2 pi f. Can you give me the value of frequency? F. Loss. Okay. Apa Atika? 795 hertz. Okay, you can calculate your experiment also. Okay, what is the value of frequency? Okay, this 30 degree is the phase shift. We call it phase shift. Okay, move to the right or move to the left. Okay, 30 degree left or 30 degree lead. Remember that term? 30 degree leading or 30 degree lagging. Still remember? Okay guys, I want to test your understanding by doing this assessment. No need to rush. You need to solve it about, I think, question 1 until 3. Can you give back to me after? As that expression, V equals to 752 sine 5,000 t plus 1. This will be the answer of question A. What's wrong? For B, calculate the steady state current by the phasor method. Phasor method. You need to change it to phasor form. How to change it? Please. B equals to. How to change this to phasor? So 750 over Z2, very good. Okay. This is in phasor form. Calculate the steady state current. You need to calculate the steady state current in the by the phasor method. So goes V equals to I Z total, right? So I equals to V over Z total. Your Z total, you just sum up all the components by changing the unit. H2 ohms, F2 ohms. Okay, sum up all the value. You will get this over R plus L plus C. Can I just write it like that? R plus L plus C in series. So you will get I in phasor method, in the phasor method. So your R will be area. Okay.
simple as that. Right? Yep. Smooth. Here. This is the circuit. The answer for A. Okay? Answer for A. This is the answer. Compare with your answer. Okay? Right? Next. Okay. This is the answer. 3.53 to the angle of negative 23 plus 1. Oh, terbalik. Oleh satu je tu. Tu naik.
Tak, saya tak. Saya makin naik, saya makin jatuh naik.
Betul lah. Betul.
Dia dah nampak dah masa depan saya. Masa degree dah masa depan saya waktu ni.
Betul turun.
Saya boleh ingat. Cek dulu, cek dulu.
Kalau ni, Syarif, ni ada kan? Syarif punya ni ada kat sini lah. Balik. Jumpa tak? Betul-betul. Yang Cik Syarif bagi orang ni transfer tu. Tak jumpa?
Bukan. Memang bukan free.
Apa pun dalam ni ke? Cari kat sini kan tu. Ikut dapat tu punya. Cari lah. Anda transfer terus. Okay. Sadia, your certificate is Zati. Nanti ada boleh. Macam mana?
Terus saya director. Dia sudah. Saya dan 5 kali kita tak semua dapat 5 kali revision untuk kimat apa festival. Dan saya nak berkenal saya baru rasa lah Dah tak tahu dia kan. Boleh sudah tahun lepas. Dia
Apa? Mana?
sama je.
Mana? Apa?
Measurement. Elsevier. Dia dalam measurement Elsevier.
Oh.
Saya dah macam tunggu pun dah macam tak tahu ni nak. Saya tak tahu tu kawan dia.
Tunggu I show you code.
Kau outer. Dia nak ikut FB tapi dia guna cakap dah tak payah. Dia ramai. Tak saya dah dulu FB lah. Dr. Linda dan Dr. Mahyu. Mahyu tu dia
Cakap profesor.
Bronson saya bayar. Tapi tak pasti ada guna tak nama Bronson sebagai saya punya supervisor. Tak, saya tak kisah pun. Tak tahu asal ke tak sebab sama dia kerja Bronson, Dr. Liao, Dr. Afizi, ini kan sakit. Tiga orang tu kan bukan tinggi kan? Sakit lah.
Semua tak sakit.
Oh sakit, dia saya dah rasa dah semua dah kan?
Dia tak sakit. Dia kecil.
Yelah semuanya pening, sama je, semua dah rasa.
Dia tadi dia kandung dia.
Yelah, tapi sambil tak boleh. Tak boleh sebab kadang-kadang kena ambil. Kadang-kadang tak ada sama level ni ke?
Tak ada.
Kak, baiklah.
Mana? Cari.
Tak, dia sini kena ambil remaja atau prof.
PhD.
Tak PhD level.
Akak je akak layak tak apa. Pembantu cik.
Doktor jadi bantu cek saya dah tadi macam mana?
Pembantu cik.
Dan
Tu je level akak.
alah, memanglah teacher baru.
Dua tahun ni mana ya?
Mana setuju tak ada.
Dah kan? Bulan tu nanti dapat jadi PhD kawan saya.
Macam nanti cik kan dia tak kan.
Kalau tu nak saya WhatsApp dia lagi.
Pasal dia aku cakap kakak.
Dia ni kan, dia
Aku dah minta ni. Dia minta dah kan ada student. Gigit lagi dah minta. 25
Kawan saya waktu
tak apa.
perempuan.
Alah.
Kawan UPNM, dia buat master kat Intel. Lepas tu tapi
Dia bagi supaya dengan Cik Syafie.
tapi Cik Syarif dia sangat opposite dengan saya Cik Syarif. Dia sangat baik, dia lembut.
Betul lah.
Tapi dia dah kahwin dah. Tapi dia baik sangat.
Baru macam Syaf. Dia cakap dia doki, dia kental. Dia kata telur ni. Iya.
kental.
Kental.
Oh.
Dia kering sikit.
Kawan saya tu memang baik. Dia
Cakap
cakap.
bila dia lembut, dia cakap.
Tak, tapi dia IPNM. Saya kena ingat. Dia IPNM. Dia masa saya karakter dia lembut. Tapi hati dia tidak lah ni.
Dia dah kahwin, dia lembut.
Aku tak ingat benda itu.
Nice.
Kau kahwin tu?
Dia gila.
Yo, pergi.
Tak, Wani kena discuss dulu. Wani tak boleh buat ni. So dia kena free. Kalau dia tak nak boleh ikut dia.
Dia fikir juga. Ini pun kita ada
Ni
choice.
dah set up dah tu. Bukan dah set up. Mesti lagi ambil test lagi.
Oh, orang tu lah.
Dia laut. Kena test lagi.
Dia punya tak.
Tak ada apa? Tak ada apa?
Tak ada nak buat apa.
Kabel.
Installation
Installation kabel. Installation kabel. Tapi akak ambil tu yang second stage punya. Yang first stage kan BD. Second stage tu
So, ni Mama apply terus testing yang saya boleh kabel ke?
Betul. Betul.
Installation lah.
Installation lah. Material ni.
Material.
Sebab kalau buat sama meeting macam hari tu, macam buat macam yang 4 orang tu, memang boleh bantai lah. Sama pun boleh bantai. Lepas tu kan, sama juga dia ni, PD.
Macam mana?
Dia kena dengan hubungan dengan Syazwani. Betul tak?
Benda ke?
Tak, betul mana tak agak lah. Syazwani lah. Lepas tu sampai saya tak boleh jawab. Lepas tu Syazwani tu jadi panel. Aku pun dia tu. Dia diam. Saya jawab dia tak berani. Dia kata, kau nak jawab apa ni? Ya.
Akak punya halat tuju akak akan pergi ke discussion yang breakdown tu lah. Akan nak pergi ke discussion tracking. Discussion tracking. So kalau discussion yang breakdown tu dia macam quantitative.
Dia sama ke tak? Dia tu buat sebelum.
Three interesting.
Oh, Daina. Okey lah.
Bukan PD, bukan breakdown lah.
Boleh okey lah.
Bukan nak Reading tu 20%. Okay.
Sampai saya PhD dah. Aku rasa aku tak nak dapat PhD. Tapi dia PhD macam tu tau. Dia rasa macam
Itu sangat. Kau bukan dia
tak,
besar.
dia perform. Maksud dia rasa macam dia writer tu dia rasa tak best. Sebab maksudnya dia rasa semua sama je. Jadi bila dia nak discuss, orang dah discuss. Maksudnya dia tak rasa mengerti yang mungkin dia buat tu. Tapi dia perform lah. Saya rasa dia dapat je untuk dia nak tukar ni. Tak tahu yang dia tak untuk daripada PhD ke.
Nanti conference.
Tak maksud saya tak maksud saya kan dia nak tukar daripada luar.
Dia macam ni. Dia macam ni. PhD ni macam mana pun novelty lah. Kalau tak boleh keluar dengan novelty tu, jadi PhD tu akan disoal.
Tapi kan
Kenapa dia tak relate dengan teori tu kan?
kalau kita dah rasa kan kita punya buat tu dah novelty. Macam mana nak macam kita nak rasa tu novelty?
Macam mana kita tak rasa?
Dia
Dengan ni minta orang lain review.
dia tak boleh.
Yang apa tahu? Yang lain bidang dia.
Bidang lain.
Faham ke tak? Yang macam tu dalam thesis tu tak faham ni. Orang lain ni lain bidang. Dia bagi masa bagi boleh tak? Minta tolong baca.
Jangan dia tak kira baca.
Kalau dia baca dia faham.
Masalah ni dia orang baca kan. Okey je. Dia kata
Satu sebab itu dia tak faham.
tak dia faham.
Dia faham, cuma dia tak faham apa dia tanya sebenarnya. Macam saya sebab saya tahu benda awak. Dia kan
Bagi tuition baca.
jangan bagi lah.
Baca.
Dia macam
mana
saya bagi baca je.
Tu lah. Dia passion membaca thesis orang ni. Tak semua pun boleh baca.
itu sebab dia
Kau kena force to understand.
Dia buat berani yang berhubungan dengan soalan tentang macam yelah, ada benda tu dia sama tulis tapi dia tak mention. Dia banyak benda macam tu.
Lepas tu satu lagi, saya tahu saya tak tahu saya macam mana, tapi kata Dr. Mona dia tak suka lengthy, dia suka yang ayat panjang. Tapi kalau Dr. Aizat punya cara pula suka panjang.
Itu cakap
Itu yang Dr. Mona terkejut. Kau hantar proposal defense, proposal tu 1 page.
dia dah habis.
Ya, dia sama thesis lah.
Dia thesis lah. Sama tu dia dah proposal thesis.
100 page. Dr. rasa master. Tapi proposal tu macam apa yang benar tapi 100 saya tak tahu benda ni. Sampai dia suruh pendek kan.
Itu depend on SD juga. Anak ni buat apa? Sebab kerana student kena yelah, dia kena ikut SD, dia cari SD. So yang
Ya, itu yang tak kata macam saya punya. Saya buat saya punya research background 3 pages je. Diorang 6 pages. Lepas tu Kak Azra mempersoalkan, Aisyah, kenapa Aisyah punya research background 3 pages je? Cukup ke? Saya kata, kenapa? Dia kata kalau Dr. Lau kena minimum 6 page. Lepas tu saya baca Kak Azra pun tak jauh dia. Lepas tu dia kata, asal bila saya cakap punya
macam cerita.
ya, bila panjang sangat, saya tak nampak apa pun dia flow tu.
Kadang-kadang panjang sangat boleh jadi repetitif. Dan benda kita ni benda nak explain sikit je. Tapi kalau kita buat bagi pada balik
Lepas tu dia jadi, orang dia jadi lost. Awalnya kita dapat grab kan, grab cerita apa. Lepas tu bila dengar, macam, ini cerita apa sebenarnya ni?
Itulah, betul lah. Supervision lah, apa-apa semua. Belajar sampai mati. Maksudnya, jadi supervisor yang baik pun belajar.
Kamu coba.
So, bila saya sama lagi, dia kata cakap, dah tak saya kau.
Ya, gaduh ni.
Saya nak mau tempat lain juga. Ini sudah tahu.
Dan kalau saya kosong, saya nak buat solar.
Thank you.
Nak sapu
for
meja
your
and
attendance.
siapa?
Thank you for coming. Okay. Saya Mona Aisyah dengan Syazwani. Thank you. Nanti akan sedikit. Okay. That's all for today. Okay. End of this course. Good luck for your future. Thank you.
Terima kasih doktor. Nanti kalau ada lagi panggilan, saya buat sikit.